Welcome to Simulation and Prototyping. For this tutorial, we're going to work with LadyBug. And so you should have that installed now, LadyBug Legacy. And this will allow us to look at environmental aspects related to our Rhino file or our geometry. What I'm going to do now is we'll start working through some of the LadyBug workflows, and we'll build this as we go. So you should have some geometry within the context of being able to analyze this. So if we go to LadyBug Legacy, for me it's LB Legacy, we can see there's a large number of tools. The first thing that we have to do with the LadyBug Legacy, you don't have to do this with the new LadyBug tool, but for LadyBug Legacy, we have to go to the first tool, which is LadyBug, and we just have to drop this in. It takes a second sometimes. Nothing happens, but this is basically running things in the background and mapping things to where they need to be. So the first thing that we're going to have to do is, like we did, and also just to make a point here that the context, this is generic context, but your context can also be grabbed using other plugins that we used before. And so I don't want you to forget about those things. Right here we have elk. We can grab data for sites from elk. I didn't do that in this case just to keep things simple. But so for LadyBug, what we're going to do is we're going to pull in some weather data. And we're going to do that using the LadyBug Import. Let's see which one. So we'll have the LadyBug Import, and we're also going to do this one. So the first one that we'll get is the LadyBug Open EPW and STAT weather files. And the way that we'll do that is there's a really useful website, and I'll pull this up now. At LadyBug Tools, or if you type EPW map LadyBug, these are weather stations. And so we can pull climate data and weather data at from any of these points. So I'm just going to zoom in to Detroit. And as we click on one of these, you'll see that there are options. We can do it at the airport as well. But as we click on this, you'll see there's a download from DOE. There's also copy link to clipboard. I'm just going to left click, copy link to clipboard, and that's going to grab a website for us. I can then minimize this file, and I'll come here. If I do // and then Control V to paste this in and enter, now we have a panel with a web address in it, and we just have to connect that web address to the URL file. And this then locates the data file. We'll connect the EPW file to the import EPW file, right? And this just parses a bunch of information for us. That second one was import EPW, which is here from the pull downs. Okay, so the next thing that we're going to do is also using that EPW file, we're going to generate a cumulative sky matrix. And so that's under visualize weather data, and then LadyBug generate cumulative sky matrix. One of the other things that's worth mentioning about LadyBug is just the amount of information that's embedded within this. And so unlike a lot of components where you click on help and there's no information, LadyBug has a ton of information. So I'm just going to drop this underneath my EPW file here and then connect EPW to EPW. There are a lot of different analysis techniques embedded within here. And so we're going to just kind of scratch the surface, but that's why it seems like it would be easy enough just to have this all working with one component, but the way that we're building is maybe not the way that you would build every time given a different analysis technique. So the one thing that we have to do is we're going to add a Boolean toggle to run it. If we double click it, that should then turn true. I think given that I'm running some other things to record, that's going to take a minute. And then we don't have an error, so that's good. Let's look at the next component that we'll add, which will be, let's see, we're going to do a selective sky matrix. And so let's see where this is. This is under it's here under Visualize Weather Data, LadyBug Selective Sky Matrix. So we'll drop this in. We're going to do a couple of things here. One is we're going to grab the Cumulative Sky Matrix and plug this in to the Cumulative Sky Matrix. Then we need HOY. And so there are some ways, let's see if I can find it here, that we could do. So there's a LadyBug analysis period where we can plug in from month, day, hour, month, day, hour, when we start and when we end. In the end, we don't need this because we're going to use every hour for the entire year. And that equates to a maximum number of elements. And so what we can do is we can create a series. And this is an easy way to tell LadyBug how many or kind of what the period we're looking at. And so I'm going to use my trick of backslash or //1 because we want to start with 1. We can copy this. Well, actually, we can plug in the 1 for also the step. And then the count, we're going to set the count to be 8760. This represents all of the data points throughout a year for all of those things. So for the HOY, we can plug that in. And so then this is working as well because we're not getting an error. I guess we could also use the analysis period if we were looking at something specific to do that. And maybe there's a simple thing to show while we're here. We'll see how specific this gets. Hour, day, month. Well, maybe we'll come back to this if there's time. I'm going to keep going, but there are some really nice visualization tools and diagrams that can be created with the information that we're working with here to help you understand where the sun is coming from, where the radiation, other things like wind, and other environmental data as well. But we've got our selective sky matrix now. Let's do what we're building to is a couple of things here. We're building to a radiation analysis. And so that's the next major component that we're going to need. And so this will be under environmental analysis and LadyBug radiation analysis. We'll plug this here and we'll plug in a few things, and we'll get ready with a few things here. One is the selected sky matrix is an element that we're going to plug in, and we're just going to have to work our way through these and fill them in. The geometry that we're going to analyze is our geometry that's going to come from our loft. And so we can grab that. We'll plug it into geometry. Context is everything else that's here. What I'm going to do is create a geometry pipeline. And the layer that we want is context. And we want to grab those surfaces from there. I'll hide this. And then I'll plug this into context. And so then we have that. This will default to north. And if you mouse over, you can see that the default north direction is set to the y-axis as 0 degrees. And so what we see on the screen right now, north is up. And so that works for us. But if we want to change that, we would change north. Grid size, let's set this to be, we'll modify this, but let's set this to be 10 as a way to start. I guess I should have said this earlier, I'm working in feet. Distance from base is the distance that the mesh will be displayed in relationship to the surface. We can set this to be pretty small. I think we can't set it to be 0. At least I think I got an error before when I set that to be 0, but we'll set it to be close to that. There are other instances where maybe we want to analyze something based on the floor geometry, but we want to show it at eye level. And so that would be an instance where maybe you want to set that, the analysis 5 feet off of a plane. But for us right now, we're just going to set this mesh to be 1 foot away from our lofted geometry. So the other things that we need are just a Boolean toggle in order to run this. And so you can see run it. And so this can also be computationally intensive to do this, but I believe that will give us, this should give us an analysis. So double click the Boolean toggle at this point, and you should see something like what we see here. The splotchiness of the surface is because we've got 2 surfaces on top of one another. So at this point, we can hide our loft. And what we're seeing now is 1 year of radiation hitting the facade of the building. And so because north is up, we're also getting a majority, or the hot spots on the southern facade. And so we can see the kilowatt hours being translated to metric. And we can see where the red zones are versus on the north side, where we can see the least amount of light hitting the surface. So this is good that it's working. I do want to manipulate a couple of things. And so what's nice is that LadyBug also has a legend. And so here we can see LadyBug legend parameters. And so we can use this. And then while we're there, under extras, there's also LadyBug gradient library. So let's grab that. And so here, if we plug in the gradient library into custom colors, we can also set something here. And if you mouse over a gradient index, you can see a number of different basic options. I forget which one I wanted to use. I forget where I started. Let's see. Oh, we can make a slider. So let's see, how many were there? There were 23 of those. So 0 is less than 23. So it'll be a nice slider to basically go through these. And then we can set this into legend parameters. And with this set to 0, that's original LadyBug. It's a little bit of a delay, but you can see now as we toggle through them, we can see a different range of colors. You might find one that you like. I want to say that maybe 20 was the one that I started with today. Now there it was 14. I like the intensity with the monochromatic color. And so the other thing that we can do while we're here is maybe to just set a few of the other parameters to really have some control over these things. And I want to set us up for the next part. And I actually want to, let's see, if we change the geometry, we'll see these values also change. So let's maybe do that briefly. And let's see. So as I change the geometry, we can see these values are also changing. And it's not maybe a terrible thing because we can see the min and the max, but actually what I'd like to do is to set these or fix them so that as we change geometry, we can see if we're better or worse, as opposed to just getting a blend of those colors. And so the way that we can fix that is the low bound and high bound related to these. And so maybe low bound I could set to be 100, and maybe the high bound can be 1000, which gives us a good range of those things. And while we're here, the number segments, well, we have a kind of large range of these. Maybe if we're going from 100 to 1000, maybe we even set that to be 9. Or 10. Okay, 10 makes sense. So we go from 100 to 1000 with a nice blend, and it's really clear what each of those values are worth. And let's set our decimal places. We can set that to 1 instead of 2, or we can set it to 0. So now we have our decimal places set there. We can also get rid of the less than and greater than symbols with a Boolean toggle. That's just a true and a false. So we'll plug that in and we'll see if that gets, I guess, false leaves them. Double click it to true. And now we just got rid of the greater than and less than symbols. All right, so this is looking pretty good. We can update some of these things if we needed to, but we've got kind of clear representation, and we've got a relatively simple model here with a description of the radiation as it hits the surface. The couple of things that we have that we might want to manipulate as we go forward, the grid size for the panels is the size of these pieces here. So if we wanted to maybe make those larger, let's see what happens if we go from 10 to 20. So that mesh gets a little bit larger. Maybe that's too large. And so what we're going to set ourselves up for soon is to be able to take the data from each of these cells and then use it to make a panel. And so we'll just find a range, maybe 15 looks pretty good. The finer you get with these, the more intensive this will be on your computer as it calculates all of those individual parts. So I just set mine to 5. We get a nice smooth gradient across the surface, but it may also slow things down a little bit too. And so it just depends on what we're doing and what stage we're at with these. So 5 looks good, but I'll probably end up going back to like 12 for the next part of our tutorial. So what I would suggest now is play a bit with your geometry, and the output from here that we're going to use for the next stage will be the radiation result, which is here. And so we can create a panel. And we can see this range. So we're going to get a chunk of, I don't know why it's split in different chunks. We can flatten this down maybe. And then we have almost 4,200 samples on there. And those will be those grid elements. And so we can see here, if we change, I'll scroll to the bottom. If we change our panel size from 5 to 10, now we have just over 1,000. And so each of these output elements, or each of the data that we see coming here, is tied to each cell on the surface. So we have that, and what we could do is, let's just get the average of these elements. Panel in there. And so what could be interesting is as you track or as you make changes, here the average of these 1,000 points on the surface and the amount of light that's hitting that surface, the average is 372. And so let's make a couple changes to our geometry and see how that might change. So if we go back, I might just look at the rotation. That's the top. Here's the rotation on the bottom. And maybe even what I'll do is I'll pull that last panel all the way over so we can see almost real time what happens as we rotate. 355. 335. So we can see that kind of having a narrower edge facing south. So if we go back to the top, it's a little bit of a delay. As I try rotate it. The sliders can also be a little bit slow as this happens. Which is why I like the panel. But for the next portion, we can start to get a sense for the opportunities that we have with the sliders. But there's a nice way that we have both a visualization of the light hitting the surface, where it's hitting the surface, but also either the average. We could also do a, what is it, the mass sum or mass addition. We could also get the mass addition of all of these so we can see the total amount of light that's hitting our facade over the course of the year. And so we could minimize or maximize that as we go. So this, now we've built a kind of malleable geometry with a number of sliders, and we've built our first LadyBug radiance analysis, and we can track those things. Let's take, we'll pause here, make sure to save your file. What I want to do next is introduce a genetic algorithm into this so that we can let the algorithm solve or try and optimize the form for us. So take a break. Let me know if you have any questions about what we've seen here. Poke around within Grasshopper. There are a lot of tutorials available online for lots of different type of analysis. So take a look at those. They will be useful. And we'll pick up with Galapagos for the third stage of the project this week.